Section 10.2 and 10.3 are really just the same section, but they were too big. So when your textbook creators created this section, they just split it arbitrarily into two sections. So the title on this one says Displaying Data Part 1. The title for 10.3 says Displaying Data to Part 2. But they're really just one in the same section, different ways of displaying data. And we're going to start, basically what we're going to do throughout both of these sections is that I'm going to define one way that data can be described, give you an example and show you how it would work, and then we're going to move to another one, okay? So the first one, and some of these are ones where you see them very, very young, so I'll do my best to kind of try and give an idea of where you might see them used in the public schools. So pictographs are one that are used even down to like pre-K. My daughter has brought these home last year. Pictographs are picture graphs used to represent tallies within categories. And we're going to use an example that you would not see used in pre-K. Okay, it's very sad actually. The Automobile Club of America considers holiday weekends to start on Friday at 6 p.m. and last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. on Saturday, 80 people by 6 p.m. on Saturday, I think there's a typo there, from Saturday till Sunday, that's what it is, and then 100 people from Sunday until Monday, draw a pictograph of the data. All right, so there's three different descriptions right here, three different numbers of things that are going on. This one says, didn't want the dotted there, 150 people before Saturday, right? And then the next piece of information says that we have 80 people from Saturday to Sunday. And then the last piece of information says that we have 100 people from Sunday to Monday. So everybody got that okay so far? Okay. So, I suspect you do not want to draw any object 150 times. Am I right? Oh, yeah. So when we're creating a pictogram or pictograph, we don't want to necessarily draw an image that represents, in this case, one person. It's not always helpful. It could be if it was small numbers, and that is what you would see when you were doing with really little ones, right? They might actually go through their class and decide what colors of eyes people have, and they'd count up the number of people with eyes, right? And then they'd draw some sort of a graph or a picture of this, right? So this is what they would do. They'd use small numbers, but these are not small numbers. So we're looking at a scenario where we wouldn't want to actually draw out 150 of an object. So we have a couple of choices, and I'd like to show you one way to do it just so that you can see what happens if you use an object that actually isn't able to be drawn a whole number of times. So the object we're going to use is a heart, and our heart is going to represent 20 people. Okay, so if I'm representing the 80 people right here, and a heart represents 20 people, how many hearts am I going to have to represent the 80 people? There's going to be 4. How about my 100 people? I'd have 5 hearts. But of course, the 150 doesn't work out quite evenly. So what would it be if I tried to do the division here? 7.5, and that's okay. Right now, we're going to just write down 7.5, just to give ourselves a reference point. So here's the way a pictograph would look. Make that a little bit thinner. So we're going to draw 3 horizontal lines. Yours will probably look more horizontal than mine. That's not too bad, actually. And I'm going to just write on them what the days are that we're talking about. So this one is Friday to Saturday. This is Saturday to Sunday. And Sunday to Monday. Okay, so a few details that are really important when we're working with graphs, and we're going to see some other graphs that have these same sort of issues later on. But whatever image you're drawing, you need to draw it approximately the same size the whole time. So I can't make some hearts really big and some hearts really small. That doesn't work. I also need to be careful about how things are lining up. So not only do they have to be on their row, right? So like the Friday, Saturday ones, I need 7.5 hearts. But I don't want it to look like this. And then somehow it's a little off center, so it's like hard to tell where they match up. Are you with me? So they also have to line up vertically for them to make sense. So here's two of mine, and I need a total of 7.5. So here's 3, 4, 5, 6, 7. And then I wanted to explain to you why I chose a heart. Some people might be like, why don't you just draw a rectangle or a square or something like that? And that's exactly the problem, is that I need to have an image that when I draw half of it, I can clearly tell I have half of that image. And when you draw a square, if you have half of the image, you might still leave the viewer of your graph going, well, did they really mean that that square is like half of the size that it was before? Like, you have to be careful. Like, could you do it with a square where you divide it along the diagonal? You could, and it would be obvious. But whatever you're doing needs to make sure that you can see that I have half of that image. And you can do that with a heart pretty nicely. Does that picture make sense so far? Do I have 7.5? Fabulous. So the next data was my 80, and that's going to be 4 hearts. So the 4 hearts have to line up underneath the 4 hearts from the previous line, like so. And then I have my 5 hearts. And again, they also have to line up evenly underneath the previous lines of hearts. Okay, so there's a couple of things you have to be careful to do. We've already done one of them. You need a key telling what those hearts mean. And I did it, right? I wrote down heart equals 20 people. So you definitely have to have that no matter what you did. And if you'd wanted your heart to equal 10 people, that'd be great. Your heart would just say heart equals 10 people and you'd have more images than I do. No problem. The second thing that every graph that we draw is going to have is a title. It's going to say, what in the world does this graph mean? Because if you give me this graph and I see hearts and people, I might think we're talking about Valentine's Day or something else. I mean, I don't know. I don't know what any of this means without the context of the question right above it. So your title gives context to your graph. So something like this. These are the deaths, and you can write it above it or below it, I don't care. Deaths on a holiday weekend. And I'll put it all in the same thing. So where the heart represents 20 people. Or you could say 20 deaths. And that's a pictograph. So obviously we're not going to use that content with the kindergartners, right? No. But the idea is very accessible to a very young child, right? Counting things up, making sure that that works. This idea of grouping people into groups of 20 to represent that image, a little bit more abstract, a little bit older thought pattern, but definitely by middle of elementary school, you're looking at being able to make that stretch, okay? You good with that one? That's pictograph. The next one is called a dot or a line plot. This is a quick way to display data with fewer than 50 values. And so here's our data. The mass in kilograms of each child in Ms. Good's class is as follows. We've got a whole bunch of numbers, and these numbers are representing the mass of each child. So one child weighs 40 kilograms, one weighs 49 kilograms, and so forth. And we're going to make a dot plot, also sometimes called a line plot, but I don't want to confuse the line word with some other things we're going to do with lines later on, so we're just going to abbreviate to dot plot for the data. So here's what we're going to do. We're going to draw a number line, and the number line is going to start at our smallest value and extend to our largest value. So take a look. What is the smallest data value in this table? Can we see it? 39. And what's the largest? 49. So as I'm drawing my number line, I need to make sure that the value, like the space in between each of my two values, is evenly distributed. All right, so like I don't want us to go 39, 40, 41. That's no good, right? They need to look like they're approximately evenly distributed. I'm not getting out a ruler on you or anything, but it needs to visually make sense. So if you decide to do 39, here's 40, 41, 42, 43, 44, 45, 46, 47, 48, and 49. And I ended up with a space at the end, so what? Doesn't matter. I've got them all roughly evenly distributed. I'll be able to work with it. You don't necessarily have to label all of them. This one doesn't have very many, so I'm going to label them. But let's say, for instance, it made more sense to label every other one. Maybe the data was a little bit more spread out, so you only labeled even numbers. Or maybe you only labeled every fifth value. That's totally fine. All right, so you don't have to label every one. I'm going to because there's not very many. Okay, so far so good? Okay, so here's where the data itself comes into play. So we're just going to go through our data, and we don't have to go through it in any order, so I'm just going to go through my data from left to right. So here's a data value of 40, and so down here where it has 40, I'm going to put an X above the 40. Again, all my X's need to be approximately the same height. Okay, the same size, I should say it that way first. And then they need to extend up the same amount of height. So for example, I don't want to have this and then this, right? So that they look like they're the same height tall eventually. That's not good. I want to visually be able to see what's really going on at a quick glance. All right, so we have 42. So I've got one at 42. 49 and 41. And we're just going through all the data, 43 and 42. Okay, when it doubles up, we do stack it. So there's 2 in the 42 column now. 48, 39. 46, 41. Now I've got 2 in the 41 column. 42 and 40. 49 and 45. 39 and 43, 47 and 44, and you wouldn't necessarily have to have all the values represented. They are here, but they wouldn't have to be. And then 49 and 42. So the point of a chart like this is that you should be able to easily look at it and say, I can see some information here. I can see that most of the values are kind of low, but I do have some sort of extreme kids, right? Some kids who are on the higher end of this like level of weights or whatever. But you can see a lot really quickly. You can see which weight's the most common, right? If you've drawn it well, you should be able to see, hey, look, most of the kids, not most of the kids, but the number of weight that occurs the most frequently is a 42, that kind of thing. And just like we did before, we have to have a title for this graph. So this is going to be the mass. You definitely need to say how it's measured in kilograms because that's different than being measured in pounds, right? Even if you're not really sure at this moment exactly what kilograms are, you haven't taken geometry measurements, you haven't worked with that kind of stuff, that's great. But they're not the same. So we need to make sure we specify the mass in kilograms of children in Mrs. Good's class. I'm going to show you one more and then we'll quit for today, and there won't be any homework on this. We'll finish this up on Friday, the whole lesson, and move into the other section, but we'll finish this up on Friday and it'll be due on Monday. Let me show you one more. Stem and leaf plot is similar to, or akin to, the dot plot. It's drawn vertically though, and the numbers on the left are called stems, the numbers on the right are called leaves. So the example 3 is grades from an exam. And it's asking us to make a stem and leaf plot for it. Okay, so the stem is the value in the tens place. The leaf is the value in the ones or the units place. So the first thing I need for you to look at is where is my smallest value, what is my smallest value, and what is my largest value. So what's the smallest value in this list of values? What one? I think it's 43. Is it? Anything smaller? Okay, what's the largest value? What is it? 94. There's one. Okay, cool. So what I'm going to do is I'm going to draw a vertical line, and I'm going to include all of the tens values from 40-something up to 90-something. So I'm going to have a 4, 5, 6, 7, and then I'm going to realize that I made it too big. It's all right. 8 and 9. Okay, and then we're going to do this a couple of times. The first time we're just going to go through kind of like we did on the dot plot. We're just going to list the values. So when I see 87, I'm going to go to the 8 row and I'm going to write a 7 on the right. And I see a 76, so I'm going to the 70s row and write a 6. 94 is the 90s row and write a 4. 58 is the 50s row and write an 8. Okay, so I've so far done those 4. 82 and 43. And I can be sloppy with this one. This is not my final answer. 89 and 53. 67 and 80. 90 and 94. 74 and 77. 87 and 74. 89 and 90. Okay, everybody good so far? So we've just sort of like piled it up. It's like we put the A's in one stack and the B's in one stack and the C's in one stack and so on. The last thing that we have to do to finish this off is to actually put them in numerical order from smallest to greatest within the row. Okay, so could you have done it all in one time? Well, you might have. I think that for me personally, I'd rather write it twice and not have to try to be so careful when I'm writing it. But that's your choice. So 6, 7, 8, and 9. So there's only one 40s, so 43 works. The 50s is the 8 and the 3, so it goes 3 and then 8. There's only one 60, so 67. 70 has 4, 4, 6, and 7. So here's the first place where I want you to be careful. It should be, the 4 should line up in the first row of this. The next 4 should line up underneath the 8, right, that's occurring up in 58. And then I have 6 and 7. Again, they should line up vertically, just like when I was working on the dot plots before and on the pictographs before. In the 80s, I have 0, 2, 7, 7, 9, 9. Is that right? I think so. Or 8, 9. Did I mess one up? No, I think it's wrong on my paper. Okay, cool. And then I have 0, 0, and 4, 4, like so. What else does my graph need? It needs a title. And the title has to include what in the world this vertical bar with the numbers on the left and the right are. So something like this. These are grades, right? Grades from a first exam. Where, and you can pick any of them that you want. Maybe you just want to start at the top, the 4-3. 4/3 means a, sorry, I'm running into all of my stuff now, means a score of 43 on the test. Does that make sense? And again, you don't have to choose the 4 and the 3. You could choose any of them from the left to the right and make sense of that. All right, we will pick up on this on Friday. We will have a test on Wednesday.